Hey guys, it's Mr. Dugal, and today we're going to talk about slope when we have straight lines present. When I say straight line, I mean we have two different options. If we have a coordinate grid, or at least a quadrant, we may see that we have a horizontal line, for example, running through one of our points. So to use lattice points to help us find the equation in slope-intercept form, we would have 0, 3 as our first point. And if we go over, it doesn't really matter how many we go over, it's always going to be 3. We find that we're at 5, 3. So when I go to find my equation in slope-intercept form, we have m equals the change in y. When we think about how y is changing, how it's going up or down, it's obviously 0. It's not going up or down. Divided by the change in x. In this case, it's 5 from one point to the other. So we would say our slope is 0 over 5. And 0 divided by any number is going to be 0. So if we go to write this, we have y equals mx plus b. When we think about our y-intercept, this line intersects the y-axis when y is 3 and x is 0. So our full equation would be y equals 0x plus 3. 0 times x is just 0. So our equation is y equals 3. And that will always be the case no matter the straight line. We might have one up here. I realize these lines aren't exactly straight, but wherever this crosses, 4, 5, 6, 7, this line is just y equals 7. So when you have a horizontal line, there isn't really the need to find lattice points and find the slope and do all that. You can just determine where the line crosses the y-axis, how far up or down the line is, and then your full equation of line is just that point. So for example, if it crossed it at, if we had a straight line that happened at -2, for example, our full equation would just be y equals -2. So that's how it works if we have a line that is horizontal. And we think about this, say we have minutes as our x-axis and pages as our y. This means that is the amount of minutes increased, the amount of pages did not increase. So this is a fake reader, someone who is letting the minutes go by but they're not actually reading any pages. Not that any of you would know what that feels like to fake read. But that's an example of how this line would exist. If as the x-axis is growing, the y-axis is not changing at all. Nothing is happening with the y-axis. The other example we have is a vertical line. So to use, we'll just use the same number. We're going to say it's crossing this time the x-axis at 3. When we go to first think of our slope, we're going to have, and again it doesn't really matter, we'll just say 5. Our 2 lattice points are 3, 0 and 3, 5. When we think about our change in y this time, it is 5. It's increasing by 5. When we think about my change in x, it's not changing at all. So it'd be 5 divided by 0 instead of 0 over 5. Now this creates a problem. We said earlier that 0 divided by anything is 0. However, dividing anything by 0 is impossible. In other words, if my two units were minutes and pages again, I can't read 5 pages in no amount of time. That's an impossible task. I know you might say, well, you could read in an amount of seconds, but even if that was the case, our minutes would be changing by at least 0.1 or so, and it would be more of a line with some type of slope. So what we say in this case is that m is The word is undefined. Also, there will be no y-intercept. This line was never going to cross. So what's our equation, you ask? Instead of it being y equals 3, the full equation is x equals 3. So instead of seeing an answer that looks like a y equals like we're used to, we just have x equals 3 in final form. And again, this works no matter where the vertical line is. So if the vertical line is at, let's say the vertical line is the y-axis, our solution would be x equals 0. If our vertical line is at -5, it'd be x equals -5. So that's how we handle slopes when it comes to horizontal and vertical lines. Hopefully this is helpful. Thanks so much for listening.